Welcome to this class. Today I am going to focus on the gravitation and Newton's law of gravitation. A meaningful understanding about these two terms is necessary for a school student. That's why I want to tell you about these two terms today. Let's start with a video clip. Look at this video clip. What is seen in this video clip? What is seen in another one and this one? All these represents the galaxy. Actually, galaxy is a vast collection of millions of stars. How they are held together, this is one of the important matter. They attract each other by a force, and this force is known as gravitation. All of them revolve around a center which is called galactic center. All the stars contained in the galaxy revolve around a center. That center is called galactic center. We are interested with the force of attraction between them, which is named as gravitation. Okay, let's take another example also. Look at this is solar system. You know about this. This is sun and the planets are revolving around the sun. And actually they held together because of force of attraction. And this force of attraction between them is named as gravitation. Now look at this another. This is the video clip which represents the revolution of moon around the earth. What is seen here, they attract each other because of this force of attraction between them, they held together. And this force of attraction is gravitation. Earth is rotating around its axis. With the rotation of the earth, the cloud, have you noticed this? The cloud which is present in the atmosphere of the earth is also rotating around the earth. What it means? Clouds are attached with the earth. The force of attraction between the earth and that cloud takes the cloud together, and the cloud also rotate around the earth along with the earth. It means they are attracted by certain force, and this force is called gravitation. Now I want to show one practical example. This lady is going to drop a brick from a certain height. Brick fell down. Again you can see whenever a body is dropped from certain height, it suddenly falls on the earth. And the same is very interesting in case of Newton. This is a story. Once Newton was sleeping just below an apple tree. An apple fell down on his head. And because of this reason, Newton started to think about this falling of the apple, why it is not moving away in the sky, and this thinking gives him an idea about the force of attraction of the earth, and then he told that this is gravitation force. Later he gave a law also, and that law gave an equation, and that can be used to calculate the gravitational force between any two bodies of this universe. Okay, till now I told you many examples of gravitation. Exactly what is gravitation? Let's say there are two bodies, and we can expect that the first body attracts second towards its center, and second also attracts first towards its center. This force of attraction between any two bodies of this universe is named as gravitation. Gravitation can be defined this way: the mutual force of attraction between any two bodies due to their mass is called gravitation or gravitational force. It is represented by a symbol F, F for force, and its SI unit is Newton. Since it is force, it is measured in Newton. Let's go forward. This is the diagrammatic representation of gravitational force between any two bodies. I want to tell you about the characteristic of gravitation. There are some characteristics which we must remember, and we'll be clear about the gravitation. First point, gravitational force produces between the bodies due to their mass, and it is always attractive force. Whether the mass is very less like dust particle or very huge like a star, if any substance, any matter has if mass, then it has capacity to pull another matter, and this force of attraction between two bodies is named as gravitation. And this force is always attractive force, never be repulsive force. I want to give some example. Just for example, this is a magnet, and if another magnet is taken near to it, unlike pole, are if taken near to each other, then they attract each other. This is attractive force. But instead of unlike pole, if like poles are taken near to each, then what is seen? They move away from each other. This is repulsive force. Gravitational force never be repulsive force. It is always attractive force. But magnetic force may be attractive force or repulsive force. We can take another example also. Look at this is a positively charged body. Another is negatively charged body. When they are brought near to each other, then they attract each other. And instead of negatively charged body, if positively charged body is taken near to the another positively charged body, then what is seen? When they come near to each other, then they repel each other. This is repulsive force. It means electrostatic force may be repulsive or may be attractive. Magnetic force may be attractive or may be repulsive, but this gravitational force is always attractive force. We have to be clear about this. Now another characteristic, gravitational force between two bodies is mutual force. What it means? Mutual force means not only the first body attracts the second one towards its center, but second also attracts first towards its center. That's why this is a mutual force. Single force doesn't exist in gravitation. Mutual force exists between two bodies, which is gravitation. Okay, now next, the mutual force between two bodies is equal in magnitude but opposite in direction. What it means? Let's say the first one attracts second one with a force 100 Newton. Then second one also attracts with the same force 100 Newton. Whether the second one is smaller than the first or bigger than the first, the mutual force between two bodies, which is known as gravitational force, is always equal. Its magnitude is equal, but they act in opposite direction. We can take another example also. Look at this is, let's say, Earth, and a body is lying on its surface, and if Earth attracts this body towards its center with a force 10 Newton force, then this body also attracts the Earth towards its center with the same 10 Newton force. Don't think that Earth is very huge, that's why Earth only attracts the body towards its center. This is completely wrong concept. We have to think just opposite of this also. If Earth attracts it with a force 10 Newton, then the body also attracts Earth towards its center by the same 10 Newton force. Okay, let's go to another characteristic. It is a force which acts through distance, whether the body is in contact or they are far away. The gravitational force between them exists. It means it acts from distance. Let's say this is Sun and this is Jupiter. Sun and Jupiter are far away from each other. Sun attracts Jupiter towards its center, and Jupiter also attracts Sun towards its center. Because of this gravitational force, Jupiter revolves around the Sun. That's why the gravitational force is the force which acts through distance. It is not necessary to bring them together or bring them near to each other. It is not affected by the presence of medium between two bodies. Just for example, let's say this is a vessel and there are two bodies immersed in water in the vessel. These two bodies attract each other because they have gravitational force of attraction. But this gravitational force of attraction between these two bodies wouldn't be affected by this water. Whether the water is present in between them or air is present between them, this medium doesn't affect the gravitational force between them. The gravitational force between them depends on their mass and the distance between them. Until and unless these two changes, value of gravitational force remains same whether the medium is present or not. Okay, let's go to another point. Presence of third body doesn't affect the gravitation between two bodies. What it means? Let's say Earth is revolving around the Sun in this diagram. The gravitational force between Sun and Earth wouldn't be affected by the Moon. Moon is also revolving around the Earth. Whether Moon is present or not, it doesn't make any difference to the gravitational force between Sun and Earth. Until and unless the mass of the Sun and Earth changes and distance between them changes, it won't be affected by any other heavenly body which are nearby this body or not. That's why presence of third body doesn't affect the gravitational force between two bodies. Okay, these are some important characteristics we have to remember related to gravitational force between two bodies. Sun attracts Earth, Earth attracts Sun. In the same way, Earth attracts Moon and Moon also attracts Earth. Do you think that the attraction force between sun and earth is equal to the attraction force between moon and earth? Attraction force between two dust particles is equal to the attraction force between sun and earth? Certainly, the gravitational force or attraction force between two bodies are different. But on which factor it depends. It was first given by Newton. He gave a law. With the help of that law, now we can understand on which factor gravitational force between two bodies varies. Let's go to the Newton's law of gravitation. According to Newton's law of gravitation, the gravitational force between any two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. What it mean? Directly proportional means if two physical quantities are related in such a way that one increases with the increase of another, then that relation is called directly proportional. And inversely proportional means what? If two physical quantities are related in such a way that when one of the physical quantity increases, another decreases, then this relation between those two physical quantities is called inversely proportional. Now, according to this law, the gravitational force between two bodies is directly proportional to the product of their masses. What it mean? If one of the mass increases, product of mass increases, and both the mass if increases, product of mass increases. Increase of one mass or both the mass increases the product of their mass and gravitational force increases. On the other hand, what is told inversely proportional to the square of the distance between their centers. What it mean? If distance increases, gravitational force between them decreases, but it is inversely proportional to the square of the distance. It means if distance is increased by twice, then gravitational force will decrease by 4 times. The gravitational force will be quadrant. This is the meaning of the Newton's law of gravitation. Conclusion, we can say, according to Newton's law, gravitational force depends upon two factors. One is mass, another is distance, and if mass increases, gravitational force between them increases. If distance increases, gravitational force between them decreases. And this law gives us one very important equation, and using that equation we'll be able to find the gravitational force between any two bodies of this universe. This is the equation obtained by Newton's law of gravitation. We are going to prove this. F equal to g m1 m2 by d square. Let's say this is first body, its mass is m1. This is another body, its mass is m2, and they are separated by a distance d. Then we can write about this. Let m1 and m2 are two bodies separated by the distance d. According to Newton's law of gravitation, the gravitational force between any two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. It means if we write mathematical expression for this law, then we can write this way: gravitational force F is directly proportional to the product of their masses m1 and m2. This proportional sign indicates that directly proportional. If the quantity, physical quantity in right hand side is given in numerator, then the same symbol says it is directly proportional. But according to law, gravitational force is inversely proportional to the square of the distance between their centers. What it mean? It means the same proportional sign will read as inversely proportional if the physical quantity in right hand side is given in denominator. It says that gravitational force is inversely proportional to square of the distance between their center. The same law is expressed in mathematical form, two equation. In both the equation, gravitational force is present. That's why we can combine these equation. Combining equation 1 and 2, what we get? Gravitational force is directly proportional to the product of m1 and m2 and inversely proportional to d square. And if physical quantities are related to each other, then there must be a constant. Whether the relation is directly proportional or inversely proportional, there must be a constant. We can change this proportional sign with is equal to sign and we'll convert this into real equation, but we have to take constant which involves between them. And so F equal to g, here g is constant. which is called gravitational constant. And this g is if taken, then proportion sign converts to equal to sign. And this is very important equation and it is proved. Now we can use this equation to solve numerical problem. After this long explanation, I want to present one of the question which makes you a little more clear about the gravitation and its relation with mass and distance. Let's analyze this question and try to get correct option. A statement is given: gravitation between any two bodies depends upon their mass and distance between them. Now think about this, I'll tell you later. Now second, argument 1, gravitation between them increases only when both the masses increases. Is this correct? Now there is another argument also. If the distance between them is doubled, then the gravitational force between them become half. These are the statement and argument. Now think about this and get the correct option from this given option. Number 1, only statement is correct. Statement and argument 1 are correct. Statement and argument 2 are correct. And argument 1 and 2 are correct. One of them is correct. Which one is correct? Now find the answer. First, only statement is correct is told. Let's check it out. Statement: gravitation between any two bodies depends upon their mass and distance between them. Is this correct? Yes. Gravitation between any two bodies depends upon mass and distance. Statement is correct. And first option is only statement is correct. Only is told. That's why we have to go through second, third also. Maybe argument 1 or argument 2 correct, or maybe both the arguments are correct. That's why we have to go to second option also. Statement and argument 1 are correct. Statement is correct, we know this. Argument 1 is also correct, told in this second option. Now let's check it. Argument 1, gravitation between them increases only when both the masses increases. What do you think? Is this correct? No. If one of the mass increased, then gravitational force between them increases. And it is not necessary to increase both the mass. That's why when both the mass increases, then only gravitation force between them increases is wrong concept. Option 2 is not correct. Now let's go to option number 3. Statement and argument 2 are correct. We know statement is correct, but argument 2, what is it? If the distance between them is doubled, then the gravitational force between them become half. Is this correct? No. Because gravitational force between two bodies is directly proportional to the square of the distance. It means if distance is twice, then gravitational force decreases by 4 times. Gravitational force will be quadrant. If gravitational force was just inversely proportional to the distance, then this argument will be correct. But in the law, what is told? Gravitational force between two bodies is inversely proportional to not distance, square of the distance between their centers. That's why gravitational force decreases by 4 times. So option number 3 is also incorrect. Now let's go to option number 4. Argument 1 and 2 are correct. Is it? Both the arguments are incorrect, previously checked. That's why we have only one correct option. What is that? First option, only statement is correct. This type of question gives you a basic concept of the subject matter. That's why I gave this question to you. This type of question checks your knowledge also. Okay, we'll meet in another class with more information about the same gravitation and numerical problem also. Thank you.